welcome to the deep dive. We're diving into some really interesting sources you brought us today, looking at a pretty massive shift happening in AI.
Yeah, it really feels like a pivot point.
We've gone way beyond AI just churning out text or, static pictures. Now, the real cutting edge seems to be creating dynamic stuff, moving content. Think realistic video, immersive 3D places, even the foundations for whole synthetic realities.
That's exactly it. These sources really map out how AI is evolving from handling, let's say, linear text or flat images to grappling with much trickier things like time, physics, actual spatial depth. It's a jump towards generating content you don't just see, but potentially experience, interact with.
Okay, so our mission today, and we're sticking strictly to the material you shared, is to unpack all that. We want to get a handle on the specific capabilities opening up, explore the implications, which seem pretty wide-ranging, and also, importantly, really wrestle with the challenges and, frankly, the responsibilities that come with these incredibly powerful new tools.
Right. And the speed mentioned in these documents is just startling. Models like Sora, which the sources talk about even from its early previews, they really signal this new era of dynamic AI generation is already kicking off.
So this isn't just for the AI researchers, is it? This impacts, potentially everyone involved in creating or consuming digital stuff.
Absolutely. Creative industries, gaming, sure, but also robotics, scientific research, education. Understanding this helps you see how digital content, virtual spaces, even the data used to train crucial systems, it's all potentially being reshaped right now.
All right, let's start unpacking this evolution then. For a lot of us, I think generative AI really landed with large language models.
Yeah.
Mastering text.
Yeah, GPT-3, GPT-4.
Yeah.
That felt like the big breakthrough initially. AI generating coherent, sometimes scarily human-like language. But fundamentally, that was about mastering sequential data, linear stuff.
Then came the image generators. You type a prompt, get a picture. Daily and mid-journey, stable diffusion. Suddenly, amazing visual power was kind of democratized.
Right. Conquering the 2D plane, you could say. Generating spatial relationships, but within a static frame. Still incredibly impressive, of course.
But now, this is where it gets really interesting, right? And these sources spent a lot of time explaining why this next step is such a big deal. The jump from static pictures to video, and not just single 3D objects, but whole worlds, that's just fundamentally harder, isn't it? Like, why is that leap so complex?
Yeah, it really is. It's about adding dimensions of complexity that, plain text or static images just don't have.
Dimension.
Exactly. The sources keep coming back to dimensionality and dynamics. Think about video, suddenly you've got time. It's not one frame anymore. It's a sequence, maybe, 24, 30, 60 frames per second?
Right. A stream of images that have to relate to each other.
Precisely. And 3D, well, that's not just flat height and width. Now you're talking depth, volume,
Color.
Actual spatial relationships in a full environment. It's a whole different ballgame.
So just vastly more data points, way more relationships between those points that the AI has to manage.
That's a big part of it. And crucially for video, you hit this challenge of temporal coherence. The sources really hammered this point. It's one thing to make one beautiful frame, but making sure that over, say, a minute of video, the objects don't just flicker out of existence.
Or change color randomly.
Exactly. Or characters stay consistent, actions flow logically. That needs the AI to hold on to a continuous, consistent understanding of the scene and everything in it across time.
Like if a glass falls off a table in frame 100, it better not be back on the table in frame 101 unless something put it back. Seems obvious, but maybe hard for AI.
It is surprisingly difficult to get right consistently. Or think about shadows. They need to move correctly if the light source in the scene changes. And then for 3D worlds and simulations, you layer on physical realism. The AI needs to somehow model gravity, collisions, how fluids behave, how light bounces around, all the messy physics of the real world.
Which is crucial if you're using it for, say, training.
Absolutely. One source gave that example of training autonomous vehicles in simulation. If the physics aren't accurate, if cars don't brake realistically or handle turns properly in the simulation, then the training is useless, maybe even dangerous, when you try to apply it to a real car.
And just keeping that level of detail and consistency going.
Yeah.
Whether it's over a longer video clip or across a huge virtual landscape, that must be a massive computational challenge. And an architectural one for the AI itself.
It absolutely is. Maintaining style or a narrative thread or consistent environmental conditions over large scales, that's a core technical hurdle these newer models are specifically designed to tackle, though it's still an active area of improvement.
So given how hard this sounds, what are these sources saying is actually driving the progress? How are we making these leaps? What's the secret sauce?
It seems to be a convergence of several things. The sources point to, well, even bigger foundation models, for one, building on the successes of LLMs and image models, but scaling them up and adapting the architecture specifically for this temporal and volumetric data.
Bigger brains, basically.
Bigger brains, yes, but also architectural innovations. Things like extending how transformers work, or adapting diffusion models, the tech behind many image generators to handle sequences or 3D space more effectively.
So smarter architectures, too.
Definitely. And maybe the most critical ingredient. Massive, massive multimodal data sets. We're talking training these systems on colossal collections of video clips, often paired with text descriptions or huge libraries of 3D scans and models.
Data appetite just keeps growing.
It really does. And underpinning all of this, of course, is the relentless march of compute power. More powerful GPUs, spiralized hardware like TPUs.
Yeah.
You just need enormous processing muscle for this stuff.
Okay, bigger models, smarter designs, tons of data, and raw power. Got it. Let's zoom in on video generation for a bit. The sources talk about AI becoming almost a co-creator. What's the state of play, say, as of mid-2025, according to these documents?
Well, the pace described is pretty breathless. They talk about models like OpenAI Sora, which had that big splashy preview in early 2024. The expectation in these sources is that by now, models like Sora are either more accessible, or we're seeing really strong competitors emerging from Google, Meta, specialized outfits like Runway ML with their Gen series.
Oh, and what can they actually do?
The capabilities discussed are pretty impressive, generating video clips that are getting surprisingly long, maybe up to a minute, even longer in some cases, apparently, and with really high visual quality.
A whole minute of coherent generated video. That's way beyond the little looping GIFs we saw initially.
Oh, absolutely. And the sources highlight qualities like pretty good character or object consistency within that minute, a decent understanding of motion, basic physics.
Like water splashing?
Yeah, one document mentioned a generated clip showing realistic water ripples when a dog shook itself off, or objects falling and hitting a surface in a believable way. They can also do things like take a static image and bring it to life, animate it, or take an existing video clip and extend it, continuing the action.
Okay, that sounds powerful.
Yeah.
But are we talking Hollywood movie quality yet? What are the limitations the sources are still pointing out?
Not quite ready for generating the next blockbuster on their own, no. Though things are improving fast. The documents consistently flag limitations around perfect long-range coherence, making sure everything stays absolutely logically consistent over, say, 5 minutes of video. Still very hard.
So the longer it goes, the weirder it might get.
Potentially, yeah. Also, handling really precise, complex interactions between multiple objects or simulating nuanced physics in very dynamic scenes, that remains a challenge. You still sometimes get these slightly surreal or inconsistent moments. One source called them hallucinations, just like you see with language models sometimes.
Makes sense.
And another big one is fine-grained control. Getting the AI to generate exactly what the director or artist has in mind, down to the smallest detail, versus just generating something plausible based on a broad prompt. That level of precise control is still developing.
How are these models actually doing the video generation? What's the tech underneath, according to the sources?
A lot of it seems to build on diffusion models, similar to image generation. The core idea, as described, is training the model to basically undo noise. It learns how to reverse a process where random noise was gradually added to clean video data.
So it learns to go from static back to motion.
Exactly. By learning that denoising process step by step, it can eventually generate a coherent video sequence, starting just from random noise, but guided by your text prompt. Often they don't work directly on the raw pixels, which would be computationally insane. Instead, they operate in a compressed, latent space.
A more efficient representation.
Yeah, think of it as capturing the essential information of the video in a lower dimensional form. Makes the whole generation process more manageable. And transformers, the architecture behind most large language models, are adapted here too. They're key for understanding the text prompts and, crucially, for modeling those dependencies across time between the video frames.
And all this.
Training on absolutely enormous video data sets, often scraped from the web, sometimes licensed, frequently paired with text descriptions to help the model learn the connection between words and visuals in motion.
Okay, taking all that capability, generating minute-long clips, animating images, understanding basic physics. What are the real-world impacts these sources are pointing towards? The creative industries must be buzzing or maybe terrified.
A bit of both, probably. But yes, the sources see it as potentially transformative there. Film, animation, advertising. They list uses like rapid prototyping of ideas, storyboarding, generating pre-visualization sequences, pre-viz.
So you can see a rough version of a scene before spending big money filming it.
Exactly. Or generating high-quality B-roll footage, or establishing shot. Maybe you need specific type of city skyline at sunset, or a drone shot over a forest. Generating that might be faster and cheaper than sending a crew out.
Interesting.
It could also assist with visual effects, maybe generate simpler animated content directly from a script, or create dynamic, personalized marketing videos much more easily. Several sources specifically called out Canada's strong creative hubs, Montreal, Toronto, Vancouver, as places likely to both adopt and innovate with this tech, given the talent pool already there.
Makes sense. What about outside of film and ads?
Education and training look like big areas. Imagine custom-made explainer videos generated on the fly, tailored to exactly what a student needs to understand. Or realistic training simulations for, say, medical procedures or emergency response drills with dynamic, unpredictable scenarios generated by AI.
That could be huge for training.
Definitely. Gaming is another obvious one. More immersive cinematic cutscenes, maybe dynamic backgrounds in games that aren't just static images, possibly even procedurally generating short video snippets within the game world based on player actions.
Wow.
And even on a personal level, it could empower individuals to create their own custom video messages, animated stories, things like that, without needing complex software or skills.
Okay, that covers dynamic visuals. Now let's shift to generating dynamic spaces. These immersive 3D simulations, entire virtual worlds. The sources suggest this is way beyond just generating like a 3D model of a chair.
Absolutely. The focus described in these readings is definitely shifting towards generating comprehensive, interactive, dynamic 3D environments. We're talking not just the geometry, the shapes, but also realistic textures, complex lighting, believable physics interactions, and even populating these spaces with AI characters that have their own basic behaviors.
Yeah, how on earth is AI pulling that off? Building whole worlds.
It seems to be a mix of techniques coming together. One approach mentioned is AI-enhanced procedural content generation, or PCG. This isn't entirely new. PCG has been used in games for ages to create large worlds. But now AI is being used to make those traditional methods much smarter, faster, and capable of generating more complex and realistic terrains, cityscapes, things like that.
So AI is turbocharging existing world-building tools.
In a way, yes. But then you also have the rise of purely generative neural networks designed specifically for 3D, things like GANs adapted for 3D, or these things called NeRFs, neural radiance fields, and 3D diffusion models. These are techniques aimed at high-fidelity 3D synthesis.
Synthesis, like creating from scratch.
Yeah, generating entire scenes from text prompts or a few input images, or creating novel 3D assets like buildings or characters. NeRFs get highlighted quite a bit in the sources for their ability to capture really detailed 3D scenes from just a handful of 2D pictures, and they can represent complex things like reflections or how light scatters realistically.
That sounds incredibly data efficient compared to traditional 3D modeling.
It can be. And then to make these generated worlds feel alive and dynamic, that's often where reinforcement learning, or RL, comes into play. The sources talk about training AI agents inside these generated 3D environments using RL.
So the AI learns by doing within the simulation.
Exactly. This lets the agents figure out realistic behaviors or learn how to achieve specific goals within that simulated world. Makes the whole thing feel much less static, more interactive.
So where does this capability generating whole interactive 3D worlds have the biggest impact, according to these documents?
Well, the applications seem pretty broad, and again, some sources link this strongly to Canadian strengths. Gaming is a massive one. This tech could radically speed up the creation of those huge, detailed open worlds players love.
Less repetitive content, maybe.
Potentially, yes. Generating more unique environments, complex character animations, maybe even enabling more emergent, unscripted narratives within games. One source flat out said this could be a major boost for Canada's already world-class game development sector.
You can see why. That's a huge part of game creation cost and time.
Absolutely. It's also seen as fundamental for building out the metaverse or whatever future interconnected virtual worlds look like. You need tools to rapidly populate these massive, persistent spaces with diverse content, working physics, AI inhabitants. Generative AI looks like a key enabler there.
Makes sense.
But one application that gets repeatedly emphasized for its practical impact is robotics training. This whole concept of simulation to real.
Oh, right. How does generating 3D worlds help train robots better?
It allows developers to create incredibly realistic, diverse, and essentially infinite variations of virtual environments, digital twins of real-world settings. Robots, whether they're self-driving cars, factory robot arms, drones, they can be trained safely and cheaply at massive scale inside these simulations before they ever encounter the real world.
So you can test them in dangerous situations without actual danger.
Precisely. You can train them on rare edge cases, dangerous scenarios, things that would be impossible or impractical to replicate over and over again in reality. A source used the example of training a self-driving car AI to handle sudden, weird events, like debris falling off a truck ahead, or complex pedestrian crossings in blizzard conditions, all safely generated in simulation.
That seems incredibly valuable for safety-critical systems like autonomous driving.
It really is. Huge potential for improving robustness and safety. Other areas mentioned include urban planning, architecture, engineering. Imagine generating multiple design options for a new building or public space, and then immediately simulating things like pedestrian flow, wind effects, energy efficiency within that generated model.
Visualizing the impact before you build.
Exactly. And even in pure science, assisting in creating or speeding up complex simulations for things like molecular interactions, climate modeling, or astrophysical phenomena.
Okay, so we've got dynamic visuals with video, dynamic spaces with 3D worlds. The sources also point to a third crucial pillar being built by generative AI, synthetic data creation. You mentioned data needs earlier, but why is synthetic data itself becoming such a big deal?
Well, as we touched on, AI models, especially deep learning ones, are just incredibly data hungry. They need vast amounts of high-quality, diverse data to learn effectively. Examples are everything.
But getting enough real data is often the bottleneck, right?
It really is. The sources lay out the common problems. Real-world data can be hard to find, super expensive to collect, and meticulously label. It's often imbalanced. Maybe the rare but critical events you really need the AI to handle well are, by definition, rare in your data set.
Like a rare disease for a medical AI.
Perfect example. And a huge issue. A lot of valuable real-world data is sensitive. Personal health information, financial records, customer data. Using it directly raises massive privacy red flags and legal hurdles. Synthetic data generated by AI offers a potential way around many of these limitations.
So what exactly is synthetic data, according to these readings? How is it different from just faking data?
It's data that's artificially generated, yes, but crucially, it's designed to mirror the statistical patterns, distributions, and characteristics of real-world data without actually containing any specific real individuals or events. The goal is statistical resemblance, not copying specific records.
So it captures the properties of the real data, but none of the specific instances.
That's the idea, and AI is the engine making this possible. The sources mention using various generative models, GANs, VAEs, diffusion models again, even adapting large language models to generate realistic-looking tabular or structured data. These tools can now create synthetic data across pretty much all modalities, images, video, text, sound, numerical data that statistically reflects the real data distributions it was trained on, or sometimes even targets specific desired distributions.
Okay, and what are the killer apps for this synthetic data? Where does it make the biggest difference?
Several key areas pop up repeatedly in the sources. First is simply augmenting real data for AI model training. If you only have a small amount of real data, you can generate vast amounts of synthetic data to supplement it, making your models more robust.
To fill in the gaps.
Exactly. And it's invaluable for balancing those data sets we mentioned, generating more examples of rare but critical cases like synthetic medical images of uncommon conditions to ensure diagnostic AI doesn't miss them, or synthetic data for unusual sensor readings for an autonomous vehicle. It helps cover the long tail of possibilities.
Makes sense. What about the privacy angle you mentioned?
That's arguably one of the most significant benefits highlighted. You can train an AI model on a synthetic dataset that was itself generated based on sensitive real-world data, like medical records or financial transactions. Because the synthetic data doesn't contain actual private information, you can potentially train powerful models while significantly reducing privacy risks and complying with regulations.
And that has particular relevance here in Canada, right?
It does. The sources explicitly mention the value of synthetic data in navigating strict privacy laws like Canada's PIPEDA. It offers a pathway to leverage the insights hidden in sensitive data for AI development, but in a way that respects privacy rules governing personal information.
That's a huge deal for healthcare, finance, any industry handling personal data. Any other major uses?
Yes, it loops back to robotics and autonomous systems again. generating huge, diverse sets of synthetic sensor data, fake camera images, LiDAR point clouds, radar signals under every conceivable weather condition, lighting, time of day.
Stuff that would take forever or be impossible to collect in the real world.
Exactly. This allows for much more thorough and safe training and testing of the perception systems these robots rely on. It's also being used in software testing, creating realistic but artificial data streams to stress test complex systems.
And the sources also mentioned something about democratizing data access.
Yeah, that's an interesting point. By creating high-quality synthetic data sets that mimic real-world patterns but are free from privacy constraints, high costs, or proprietary restrictions, you could potentially give researchers, startups, students access to data they couldn't otherwise get. This could really level the playing field and spur wider innovation.
Wow. Okay, so the potential across video, 3D worlds, synthetic data, it's clearly immense. But the sources don't shy away from the downsides. This brings up that crucial question. What are the big challenges and responsibilities we need to be thinking about with these advanced generative AI forms?
They definitely dedicate significant space to this, and it's critical. The documents outline several major hurdles and ethical considerations. One that keeps coming up is just the sheer computational cost and accessibility.
Right, needing supercomputers.
Pretty much. Training and even just running these massive models for high-res video, complex simulations, or large synthetic data sets takes enormous computing power loads of expensive GPUs or TPUs.
Which translates to high energy consumption.
Yeah.
And probably limits who can actually develop and use this tech at the cutting edge.
Exactly. It raises serious environmental concerns about the energy footprint, and it creates a potential divide where only large corporations or well-funded research labs have the resources to play. Accessibility is a real issue.
What other challenges?
Control, coherence, and intentionality. We touched on this with video, but it applies broadly. While the outputs are getting amazing, ensuring users can reliably get the exact result they want, maintaining perfect consistency over time or space, avoiding weird artifacts or glitches, ensuring simulations are always physically plausible, it's still hard. You want the AI to be a predictable tool, not just a sometimes magical, sometimes frustrating black box.
You need to be able to steer it reliably. Okay, what about the more potential for misuse?
Yeah, that's probably the elephant in the room, and the sources are very clear about it. The deepfake dilemma and the broader issue of misinformation. The ability to generate highly realistic synthetic video, audio, even simulated events or conversations just pours gasoline on the fire of malicious deepfakes.
Like those CEO voice scams.
Exactly. The documents mention sophisticated fraud, faking a voice to authorize a wire transfer, for instance, but also political manipulation, creating fake videos of politicians saying things they never said, manufacturing evidence of events that never happened, defamation, spreading potent disinformation that's incredibly hard for the average person or even experts to debunk quickly. And the tech to detect these fakes, it's constantly playing catch-up. It's an arms race.
That potential to just completely undermine trust in anything we see or hear online, that feels genuinely scary.
It's a fundamental challenge to what the sources call digital authenticity. And tied into this is the whole legal and ethical mess around intellectual property and copyright.
Yeah. Who owns the stuff the AI makes?
Exactly. Is it the user with the prompt? The company that built the AI? Is it just a public domain? Huge debate. And an even thornier issue raised is the training data. These models learn by analyzing vast amounts of existing content, images, videos, music, 3D models scraped from the internet. A lot of that original content is copyrighted.
So creators are worried their work is being used without permission or payment to train systems that might eventually replace them.
That's the core tension, yes. The legality and ethics of using copyrighted data for training is a massive global debate right now, with huge implications for creators and creative industries, including right here in Canada. Finding a fair balance is proving really difficult.
You can see why. What else? Bias.
Definitely. Bias amplification and representation. It's a recurring theme in AI ethics. Generative models learn from their training data. If that data reflects existing societal biases, skewed representation, harmful stereotypes, historical inequities, the AI will learn those biases too and potentially amplify them.
So it could generate videos or characters that reinforce stereotypes?
Precisely. Or create synthetic populations for simulations that don't accurately reflect real-world diversity. This is a huge concern, especially if the AI outputs are used in sensitive areas like hiring, loan applications, or even just shaping cultural narratives, garbage in, biased garbage out, potentially.
The AI just reflects the flaws in its learning material.
It does. And maybe underlying many of these issues is a final challenge the sources point to. Authenticity and what one called the reality default. As generative AI gets better and better at creating fake stuff across all media, video, audio, images, text, simulated environments that looks and sounds completely real.
It gets harder to tell what's real anymore.
Exactly. The very line between authentic and artificial blurs. This could seriously erode our general trust in digital information, making it much harder for people to know what to believe online. That has potentially quite destabilizing consequences for society.
That fundamental shift in how we perceive digital reality, that's a profound impact.
It really is. The sources frame this less as just a tech problem and more as a societal adaptation we're facing.
Okay, let's try to synthesize this. Bringing this deep dive towards a close, drawing from everything in these sources, what's the big picture takeaway here? What's the significance of generative AI making this leap beyond text?
I think the sources collectively paint a picture of AI profoundly expanding its capabilities. It's moved from being primarily analytical or text-image focused to becoming a powerful engine for creating dynamic content and complex simulations, realistic video, intricate 3D worlds, invaluable synthetic data.
It's unlocking new possibilities everywhere.
Right. Huge potential for innovation and efficiency gains across so many sectors. Gaming, film, robotics, science, education, you name it. It feels like a new paradigm for creation and simulation is emerging.
But there's always a but.
But, as these documents really stress, this incredible power comes with equally profound responsibilities. The challenges we just discussed, the cost and access issues, the need for better control, the very real threat of deepfakes and misinformation, the IP battles, mitigating bias, preserving a sense of authenticity. These aren't minor footnotes, they're central.
And tackling them isn't just on the AI developers.
No, the sources emphasize it requires a concerted effort from everyone. Researchers need to push the tech forward responsibly. Developers need to build in safeguards and ethical considerations. Policymakers need to craft smart, adaptable regulations. And the sources note Canada is actively working on its AI strategy and data governance frameworks. Industry needs to adopt ethical best practices. And all of us, as users and citizens, need to become more critical consumers of digital media.
So it's not just about the amazing new tools, but about how we choose to build and use them and the kind of digital world we want to create with them.
Exactly. Generative AI beyond text isn't just about making cool digital things. It's fundamentally forging new ways to be creative, to simulate complex systems, to train both humans and machines, and potentially to solve really hard problems. The key is navigating that potential wisely.
Which leaves us with maybe one final thought to chew on. Building on that idea of AI as a collaborator. As these incredibly sophisticated technologies keep maturing, as they act more and more like genuine partners in creative work or scientific discovery, what does that ultimately mean for our own definition of human creativity itself?
That is a really fascinating question to ponder as this all unfolds, isn't it?
It really is. Well, thank you for walking us through these sources. This has been a truly eye-opening deep dive into where generative AI is heading next.
My pleasure. It's a rapidly evolving space.
Absolutely. And if you found this discussion insightful, please do subscribe to our channel, Tech AI and Beyond. We'll keep bringing you deep dives into the technologies shaping our future.